If f is a probability mass function for a discrete random variable, we can find the mode by finding the ratio between consecutive probabilities. As long as the ratio is greater than 1, the next probability will be greater, but if the ratio becomes less than 1, the next probability will be less. And as long as f is a continuous function, even if f is discrete, once the probabilities start to decrease, they will continue to decrease. But remember, if you don't find your mistakes, somebody else will. So, suppose x is a discrete random variable with probability mass function. Let's find the mode. So we'll find the ratio of the probability that x is equal to some value and the probability that x is 1 more, and that will be So note that if x equals 0, the ratio is 65/60ths, which is greater than 1. And if x equals 9, the ratio is 20/33, which is less than 1. So somewhere the ratio changed from being more than 1 to being less than 1. So I can try and find where that happened. If our ratio is equal to 1, we can solve and find And so the ratio is equal to 1 when x is 2.5. Since we determined the ratio changed from greater than 1 to less than 1, this change had to occur at x equals 2.5. Now, since this is the only place the ratio could have changed, it means that for x less than 2.5, the ratio of consecutive probabilities is greater than 1, and for x greater than 2.5, the ratio of consecutive probabilities is less than 1. This means the probabilities are increasing up to and including x equals 2, and the probabilities are decreasing after x equals 3. And be careful with that, because this means that the ratio of the probability that x is 3 to the probability x equals 2, since 2 is less than 2.5, that probability ratio is still greater than 1. So the probability x equals 3 is greater than the probability x equals 2, and by extension, because the ratio is greater than 1, that probability is greater than the probability x equals 1, which is greater than the probability x equals 0. Likewise, since 3 is greater than 2.5, the ratio of the probability that x equals 4 to the probability x equals 3 is now less than 1, which says that the probability x equals 3 is greater than the probability x equals 4. And since all of our ratios after this point are also less than 1, we can extend it, and so our probability that x is 4 is greater than the probability x equals 5, and so on. Since the probability x equals 3 is greater than these probabilities and greater than the other probabilities, then the probability x equals 3 is the greatest probability, and the mode will be at x equals 3. It's important to go through this analysis, because if you don't, well, let's see what happens. Suppose x has a probability mass function. We'll find the mode. So we'll find that ratio between consecutive probabilities, and then we'll set the ratio equal to 1 and solve. And we find x equals 2. And this means that the ratio of the probability x equals 3 to the probability x equals 2 is 1. And so the probability x equals 3 is the probability x equals 2. And since these probabilities are equal, then we have a bimodal distribution with two modes, x equals 2 and x equals 3. Or do we? While it's true that the probability x equals 3 is equal to the probability x equals 2, we don't actually know if these are the highest probabilities. In fact, we find the probability x equals 1 to the probability x equals 0, that's 6/10, which means the probability that x equals 0 is actually greater than the probability x equals 1. And by extension, because we don't get equality of the ratios until we get to probability x equals 2, we know that that's greater than x equals 2, which is equal to x equals 3, which actually makes x equals 2 the least likely outcome. And we can come at it from the other direction. The ratio of the probability that x is 10 to the probability x is 9 is, which is greater than 1. And so that tells us the probability x equals 10 is greater than the probability x equals 9. And again, by extension. And so x equals 3 is also the least likely outcome. And what that tells us is the probability x equals 10 is greater than most of the probabilities. The probability x equals 0 is greater than all the rest. And so one of these is the most likely outcome. And here we actually have to find the probabilities, which are, and so x equals 10 is the most likely outcome, and so this is the mode.